Okay, welcome back. Let's do a bunch of practice for plug-in and backsolve. So looking at this problem, what are they asking us for? They're asking what is the value of x minus 3? We're looking for a value. So this is going to be backsolve. Look, the answer choices are a list of numbers. We can just try it back in the problem for x plus 3 and see if it works. So looking at this guy here, I notice if I factor out a 2, so I'm going to take that 3. I'm going to factor out a 2. I'm going to be left with x minus 3, this thing that I'm looking for. Yeah? Equals 4. Let me make it a little smaller. 4 times the thing that I'm looking for plus 6. So now I can use my calculator, and instead of writing x minus 3, I can pop in my answer choices. So let's start in the middle. Let's put in, instead of x minus 3, let's put in 15 over 2, and we'll see if it works. So notice I can plug in for an expression, not just a single variable. So I'm going to put my little parentheses here. I'm going to have in my parentheses 15 over 2. That's my little fraction guy. I'm going to close a couple of parentheses here, minus 11. Hit enter. Okay, I got 34. Now for this other guy, I'm going to go 15 over 2 plus 6. See what I get? 36, not my guy. So let's cross this out. I think it's really hard to tell here whether I should go bigger or smaller. So I'm just going to pick a direction and go. It seems like my positive ones are pretty close together. So let me try another positive. Let's try 17 over 2. So we'll change that little 5 to a 7. And if I have a calculator that I can pick and do again like that, just select and re-enter, I can just go back and edit this one to be a 7. And I don't really have to type it out again. So that's 40. Now if I take this one again and I change that 15 for a 17, hit enter. Ooh, it's 40 as well. This makes them equal as I wanted them to be. So that's my answer. How fun. All right, let's try the next one. So here we're looking for what is the value of x in, for what value, let me try that again. What value of x is the solution to the given equation? Okay, let's find out. What do we want x to be? Well, x could be any of these guys. So let's start in the middle. We have 1/4 x plus 5. I'm going to leave a little blank space for my x, plus 1 over 3x plus 5. And that's supposed to equal -7 when I pop my x in. So let's try, let's try 79 to start. That looks like a promisingly weird number. So let's go to our calculator. Anytime I enter a fraction, I'm always going to put it in parentheses unless I'm using a fraction bar. So we have that here. 1/4 in parentheses 79 plus 5, close parentheses, minus, and again I'm doing a fraction so I'm putting it in parentheses, times 79 plus 5, close parentheses. If I hit enter, ooh, I get -7. Oh, isn't that so fun when you get it on the first try? I love that. Okay, we'll pick this guy here because it worked out. Just if you do have the TI-84, if you hit alpha y equals, you'll also be able to pick number 1. That'll enter a little fraction for you. So you would be able to enter it like 1/4, like that. Just an option. Or you can do parentheses, whatever is easiest. All right, let's do another one here. Again, we're back solving. The question says, if 2 times x minus 5 plus 3 times x minus 5 equals 10, what's the value of x minus 5? And again, x minus 5, we have a list of numbers and the answer choices. We can just pop those back in for x minus 5. So let's try it. My equation is 2 times x minus 5 plus 3 times x minus 5 equals 10. All right, so I'm going to replace my x minus 5 for the answer choices. Not x this time, x minus 5. So let me erase my x minus 5s. And let's try, let's try 7. Let's put a little 7 in there. Put a little 7 in there. And let's punch that into our calculator. 2 times 7 plus 3 times 7. Does that equal 10? Ooh, that's too big. So not only can I eliminate 7, I could probably also eliminate 12. Let's try 5. I put a 5 in there. 2 times 5 plus 3 times 5. Ooh, 25. That's still too big, so let's get rid of that one. Let's try 2. What happens if we pop a 2 in there? All right, here we have 2 times 2 plus 3 times 2. What have we got? 10. That's our answer. Here we go. Let's try another one. Now look at this one. This one looks different. Do you see how the answer choices aren't a list of numbers? There's a bunch of variables in there. That means this one's going to be a plug-in. So the width of a rectangular dance floor is W feet. So let's extract the information. Let's make ourselves a little rectangular dance floor. Let's put W on there for our feet. Now, I see the W in the answer choices. You know what I'm going to do? I'm just going to plug in right away. I'm going to make that W, 4. Okay, so I'm going to say this is 4. The width is 4 feet. So you know what? I'm going to put a little 4 right here. A little box around the number I picked. You know how we go. The length of the floor is 6 feet longer than the width. So 6 feet longer than 4 would be 4 plus 6. That'll give me 10 for my width. Now what are we looking for? Which of the following expresses the perimeter in feet of the dance floor in terms of W, which we know is 4. So let's see, what would the perimeter be? Well, remember, the perimeter is the outer edges added together. So this plus this plus this plus this. So it'd be 4 plus 10 plus 4 plus 10. So that's 14 plus 14. That's 28. 28 is the perimeter. And what do we say? In goes the box, out comes the circle. So looking at answer choice A, that'll be 2 times 4, our W, plus 6. It gives us 14, not what we're looking for. The next one is 4 times 4 plus 12. Well, that gives me 28. That's what I'm looking for. Should I try the other answer choices? Absolutely, positively, yes. Because what if another one gives us 28? We don't know yet. All right, let's take that 4. Let's square it. Let's add 6 to it. And what if we get 22? That's too small. Let's get rid of that. And then the next one, we have 4 squared plus 6 times 4. And what do we get? 40. Too big. Let's get rid of that guy too. All right, looks like we found it. Let's look at our next guy. Okay, how many solutions does the given equation have? So I want to know how many things will work in here. Well, let me try. Either 1 will work, 2 will work, or infinitely many will work. But let's see, or maybe 0 will work. But let's see if we can find anything that works. We have 66x equals 66x. Maybe I'll plug in here because again, they're saying it might not matter. So let's pop in a 2. If I do 66 times 2 equals 66 times 2. Wait a minute, just looking at that with my eyeballs, I can tell you that's going to work. So 2 works. What if I put in a 3? Well, 3 works. That's at least 2 that work. So I'm going to get rid of exactly 1 and 0 because I at least found 2 things that work. If I can find even 1 more, it's not going to be exactly 2. So the answer would be infinitely many. What if I had to put a little 5 in here? Well, yeah, the same z's, so I think our answer is going to be infinite many solutions. Now, this one here, if you notice what we're looking for, we are looking for, at the end of the day, what is Megan's regular hourly wage? And we have a list of numbers. That's not a relationship, so that's going to be a back solve. Megan's regular wage at her job is P dollars per hour for the first 8 hours of work in a day, plus 1.5 times her regular hourly wage for work in excess of 8 hours that day. On a given day, Megan worked for 10 hours and her total earnings for that day were $137.50. What is Megan's regular hourly wage? So that's a lot of information, so let's make sure we extract it. She gets P dollars an hour per hour for the first 8 hours, plus 1.5 times her regular hourly wage, which we know is P, for anything that's over 8 hours. On a given day, she worked for 10 hours, and she made a total of $137.50. That's her total amount. All right, so now we can just test out the answer choices and see which one gives us a wage that if she worked for 10 hours, we'd be good to go. So let's try that. Let's put in, let's say $12.50 for P. put in $12.50 per hour. And then that's for 8 hours. And then 1.5 times $12.50 for anything over 8 hours. Well, over 8 hours, if we're working 10 hours, that's going to be 2 hours that we're working over 8 hours. So how much is this going to allow her to make if we're working 8 hours at $12 an hour, or $12.50 an hour rather? We do 8 times $12.50, and let's see what we get. 8 times $12.50, and we're going to get, she made $100 in those 8 hours. And she worked another 2 hours at 1.5 times $12.50. So that's 2 times 1.5 times her $12.50. And that gives us another, so sorry, I write that down. That would be 2 times 1.5 times $12.50 times $12.50. And that gave us 37.5. Now, how much did she make altogether here? 100 plus 37.5 is 137.5. Is that what we wanted? Oh my goodness, it sure is. Oh, it's so fun to get it on the first try. So that's our answer. All right, we've seen this guy before. If 5 times x plus 4 equals 4 times x plus 4 plus 29, what is the value of x plus 4? We're looking for what is the value of x plus 4. Do we remember what this is? This is going to be a back solve. We're going to pop the answer choices back in for what? X? No. For x plus 4. So if we have 5 times x plus 4 equals 4 times x plus 4 plus 29. Let's see. Let's go ahead and swap out our x plus 4s for, how about a 29? Let's put a little 29 in there. All right. 5 times 29. That's going to give us 145. And then on the other side, what do we have? We have 4 times 29 plus 29. Ooh, 145 also. Looks like that one worked out. So let's circle that up. Very good. All right, let's take a look at the next one. We have a times 3 minus x minus b equals -1 minus 2x. In the equation above, a and b are constants. If the equation has infinitely many solutions, what are the values of a and b? So let's see. They're telling us what a and b are. They just give us a bunch of different options. So if we're looking for what a and b are and they give us a bunch of numbers, we can just back solve this. So let's go ahead and write out our equation. A times 3 minus x minus b equals -1 minus 2x. So now let's go ahead and try out one in the middle. Let's try b. I'm going to swap out a 2 for the a. So let me get rid of the a and put a 2 in. And a 7 for the b. All right, let's simplify this side, left-hand side, so maybe we can see if it looks like the right-hand side. Because if the left-hand side and the right-hand side are the same, then everything will work infinitely. Anything will work, and that's kind of what we're looking for, because it asked us for something that would have infinite many solutions, meaning anything would work for x. So we distribute or there's an infinite number of things that would work for x, not anything. We'll go ahead and distribute the 2. We'll get 6 minus 2x minus 7 equals -1 minus 2x. Let's simplify the left-hand side. 6 minus 7, that's -1 minus 2x equals -1 minus 2x. Ooh, this looks like a good candidate for infinitely many solutions. Now, we can prove that to ourselves by adding 2x to both sides and adding 1 to both sides. Notice this will cancel, we'll get 0, equals, this will cancel, we'll get 0. Question for you is, how many values of x cause 0 to equal 0? Well, literally any value of x will do that. So that means we have infinite solutions, and we found the right answer right there. All right, let's look at the next one. b minus 2, quantity b minus 2 times x equals 8. In the given equation, b is a constant. If the equation has no solutions, what is the value of b? Okay, let's see. We want to know what b is. So let's think about this. We can get a bunch of different values for B in the answer choices, so we can just try them out. Now, how will we know if it has no solutions? Well, let's give it a look. You'll be able to notice when we do it. So let's try 4. Say I'm going to put 4 in for B. First, let's write out our equation. And then again, we're looking for the value of B. So we're going to put the answer choices back in for B. Let's get rid of B and let's put a little 4 in there. 4 minus 2, well, that's 2. 2x equals 8. Let's see if I can get a solution for x. Let's divide both sides by 2. Well, x equals 8 over 2, or 4. That looks like a solution to me. So probably we're looking for no solution. Well, it says we're looking for no solution. So let's get rid of this guy. That didn't work. That gave us a solution. We're looking for no solution. So let's try, I don't know. Let's try 6. Let's put a little 6 in there. That'll give us 4 times x equals 8. Well, if I divide both sides by 4, I'll get x equals 2. Wait a minute, that's a solution. I wanted no solution. So let's get rid of this guy. Okay, let's try again. Let's try 10. I'm going to pop a 10 in here. Okay, that's 8. 8x equals 8. Divide by 8. Oh no, I got another solution. 1 is a solution. I don't want that. No. All right, guess I got a little unlucky on this one. Let's try 2. Let's pop a 2 in. 2 minus 2, well, that's 0. 0x equals 8. Well, 0 times x, well, that's just 0. Is it ever true that 0 equals 8? No way. That sounds like a fake answer. That's a no solution situation. There's nothing that you could put in for x that would make 0 times it equal 8. Very good. All right, let's look at this next one. Ooh, do you see all those variables in the answer choices? This is going to be an excellent plug-in. Let's try it. Which expression is equivalent to 4 over x minus 4x minus 5 minus 1 over x plus 1? So let's try it. What should we make x? I don't know. I love a good 2. So let's make x equal to 2. So I'm going to pop that into my original equation and say 4 over 4 times 2 minus 5 minus 1 over 2 plus 1. Notice I replaced all my x's with 2. So now I'm going to put that in my calculator to see what it is. I'm going to do my little fraction bar here. So 4 in the numerator, 4 times 2 minus 5. And then I'm going to use my little right arrow to get out of there and do subtraction. I'm going to grab another fraction bar there and do 1 over 2 plus 1. Let's see what we get. Oh, we get 1. All right. In goes the box, out comes a circle. I'm going to pop in a 2 and see which one gives us a 1. Okay, so let's see. We put a little 2 in answer choice A. That'll be 1 over, this is 2 plus 1, that's 3. And this is 4 times 2, which is 8, minus 5. 8 minus 5, that's 3, 2. That's going to be 1 over 9. That's not 1. Let's get rid of that guy. This guy here is going to be 3 over 3 times 2 minus 6. That's a little bit weird because that's giving me 3 over 0. That's undefined. So I'm going to say maybe this jury's still out on this one. Yeah, because if it's undefined, I might have just gotten unlucky with a number that I picked. So let's keep that one in. It's undefined. Let's try C. Okay. C, I'm going to take it down here to give us a little more room. C is negative 1 over, that's 2 plus 1, 2 plus 1, times 4 times 2 minus 5. Okay, let's see what that is. I'm going to punch that into my calculator. It's negative, though, so I'm suspicious about this already. Negative 1, I'm going to grab my fraction. Oopsies, I should put negative 1 in my numerator. Grab my fraction first. Negative 1 over 2 plus 1 times 4 times 2 minus 5. Let's see. Oh, no, that's not the guy. That's a little bit different than 1. All right, now how about this last one? D, 9 over 2 plus 1 times 4 times 2 minus 5. So let's put that in our calculator. We have 9 in the numerator over, in parentheses, 2 plus 1, in parentheses, 4 times 2 minus 5. Ooh, that one gave me 1. Now, if I was in a bit of a rush, I would just pick D. Otherwise, I might pick new numbers and try again. In this case, D is correct because, again, if it was equivalent, we might have gotten something undefined for our original equation too. So D's our guy because it gave us the one that we were looking for originally. All right, let's try this next guy here. This one's a little bit spicy. Let's see, it says, in the expression 3 times quantity 2x squared plus px plus 8 minus 16x times the quantity p plus 4, p is a constant. This expression is equivalent to the expression 6x squared minus 155x plus 24. What is the value of p? Well, this is a plug-in or backsolve. Think to yourself. See all those numbers in the answer choices? We could really just try them out and stick them back in for p. So this is a backsolve. So let's copy out our original equation. Our original equation is 3 times 2x squared plus px plus 8 minus, let me give myself a little more space there, 16x times p plus 4. And I know that has to simplify to this guy here. So let's start in the middle. Let's start with 7. And I'm going to put that back in for what we're solving for p. So let me put 7 in for p. And then let's simplify. Let's go ahead and distribute the 3 to all these things. So I'm going to get 6x squared plus 21x plus 24. And then I have to remember I'm distributing this whole thing to both of these guys here. But you know what? I can actually simplify this so I don't have to distribute. 7 plus 4, well, that's just 11. 11 times negative 16 times 11 is going to give us negative 176x. So now we have to combine like terms. We have 6x squared, and then we have our linear terms here. So let's see what that is. 21 minus 176. Oh, that gives me negative 155x plus 24. Does that match what I'm looking for originally? It certainly does. So it looks like I landed on that right p first. Again, just popping it back in the equation, trying it out, simplifying to see if I get what I'm looking for. All right, let's take a look at this next one. Yikes, look at these exponents, but no worries at all. I got all those variables in the answer choices too. So it says the expression x to the negative 2, y to the 1/2 divided by x to the 1/3, y to the negative 1, or x is greater than 1 and y is greater than 1 is equivalent to which of the following? Okay, let's see. So if we're going to plug in, they gave us some restrictions. X and y both have to be greater than 1. So I'm going to make x, I don't know, 8. And I'm going to make y 4. Keep it nice and neat. Okay, so let's see. I'm going to put into my calculator. I want to find out what this equals in real numbers. So I'm going to have 8 to the negative 2, 4 to the 1/2 divided by x, 8 to the 1/3, and then y, which is 4 to the negative 1. So I'm going to punch that into my calculator. I'm going to go grab my little fraction bar. In the top, I'm going to do 8 raised to, that's that little up caret, negative 2, times 4, little up caret, to the, I'm going to grab myself another fraction there, 1/2. Okay, I'm going to go down to my denominator, and I'm going to say 8 raised to the, let me grab my little fraction again, 1/3, and then I'm using my little side arrow to get out of there, times 4 raised to the negative 1. If I hit enter, I get 0.0625. So let me put my box and my circle, and I say in goes the box, out comes the circle. So let's try answer choice A. I'm going to grab my little fraction bar. That's the square root. Where's my square root button on here? Why am I missing that? I'm not very used to this calculator, but let's see, maybe it's under functions. I bet it's under math. There we go. We'll have our little square root. We'll put a little 2 there because it's the square root of y, which is 4, So again, we're doing a now, putting a little 4 in there. And then in the denominator, I'm going to go back to my math button. And I'm going to grab, this time, the cube root. And, oh, no, that's cube, not cube root. I'm going to go back to my math button. I'm going to grab my cube root of x, which is 8. I'm going to square it. I'm going to hit enter. Oh, it's not what I wanted. So we'll get rid of that, guys. We're going to put an 8 for that. Go cross that out. Now we're going to grab my fraction again. And I'm going to put in, again, 4 for my y and 8 for my x. So in my numerator, I have 4 square root 4. And in my denominator, I have 8 square root 8. I'm going to hit enter. Not what we wanted. All right, let's try this guy. We're going to have 4 square root 4. Wait a minute. Oh, yeah, we just tried this guy. So now we have to try D. Let's try D. We're going to have 4 square root 4 over 8 squared cube root of 8. So let's grab our fraction again. We're going to have 4 square root 4 over 8 squared times the square root, or the cube root rather. So let's go grab the cube root of 8. That's what we wanted. We found it. Look how we could just use our calculator to get around knowing all these crazy exponent rules. All right, let's do another one. This says f of x is x cubed minus 9x, and g of x is x squared minus 2x minus 3. Which of the following expressions is equivalent to the f of x divided by g of x for all x is greater than 3? Look at all those variables in the answer choices. This is going to be a plug-in. So what do we want x to be? Let's make x, oh, I don't know, something cute and small, 2. So now I'm going to replace in my equations. I'm going to zoom in for this guy. I'm going to replace my x's with 2. So I want f of 2, which means I pop a 2 in for my x as well. 2, pop a 2 in for my x. Okay, so put a 2 in for my x's here as well. Okay, so what is f of 2? So basically what I want now is f of 2 divided by g of 2. So let's figure out what those are. In this top equation, f of 2 is 2 cubed minus 9 times 2. Well, that's going to give me negative 10 in my numerator. And in my denominator, I'm getting 2 squared minus 2 times 2 minus 3. That gives me negative 3. So it looks like what I have here is 10 over 3. Or if I'm doing 10 over 3 as a decimal, it'll be 3.33 repeating. Yes? So let's pop a 2 in the answer choices and see which one gives us the same thing. If I put a 2 in here, I'm going to get 1 over 3. That's not 10 over 3, so let's cross that out. If I put a 3 in here, a 2 in here, I'm going to get 5 over 3. That's not 10 over 3. Cross that out. This guy here, I'm going to get 2 times 2 minus 3 over 2 plus 1. Well, that's going to be a negative 1 in here. That's going to give me negative 2 over 3. That's not what I'm looking for. And then this guy over here, this is 2 times 2 plus 3 over 2 plus 1. That's a 5 in there. So that's 2 times 5. That's 10 in the numerator and 3 in the denominator. That's what I wanted. So D is my answer. Let's take a look at the next one. We have this expression, 1/3 x squared minus 2 can be rewritten as 1/3 quantity x minus k times quantity x plus k, where k is a positive constant. What is the value of k? Well, they give us a bunch of options, so I think we can just back solve this one. So let's try it out. We have here, maybe we can say k is the square root of 2. Let's try it. So I'm going to put that back in for k. So I have 1/3 x minus square root of 2 times x plus square root of 2. Okay. Well, if I'm going to simplify it and make it look like this, I think I have to FOIL it out. So we have 1/3. When I FOIL this guy out, first, x times x is x squared, outer, plus radical 2x, inner, minus radical 2x, and then the last, negative 2. So when we simplify this, these guys will cancel each other out. I'll get 1/3 x squared minus 2. Now this one looks like we distributed the 1/3, so even though it kind of looks the same, when we distribute it, you'll see it doesn't really look the same. We get x squared 1/3 x squared minus 2 over 3, because 2 times 1/3 is 2 over 3. That's not the same, so let's cross this out. All right, let's take it back, and we'll try the exact same thing, but this time, let's do it with radical 6. Okay, I'm going to change that for radical 6. We're trying D. So when we FOIL this out, I'm going to do it nice and quick. We're going to get x squared plus radical 6x minus radical 6x minus 6. So these guys here are going to cancel each other out. And we're going to get 1/3 times x squared minus 6. When I distribute the 1/3, I get 1/3 x squared minus 2. And that is what I'm looking for. So this is my answer. All right, let's try this guy. Which of the following is equivalent to quantity a plus b over 2 squared? All right, well, let's think about this. Let's notice those variables in the answer choices. This is going to be a plug-in. Let's try it out. So what do we have here? We have, maybe we can make a 5 and b 6. How does that sound? So let's see what this would be with real numbers. We have 5 plus 6 over 2 squared. Let's see what that would be. That's 5. 6 over 2, that's 3. So I'm just going to punch this into my calculator. 5 plus 6 over 2 quantity squared. Let's see what we get. 64. Okay, so we're looking for 64 when a is 5 and b is 6. Let's try out a. I'm going to pop in 5 for a and 6 for b. So I have 5 squared plus 6 squared divided by 4. It's going to give me 32, not what I wanted. All right, let's try the next one. This is going to be 5 squared. Oh, whoops. I tried b first. Did you see that? I divided by 4. I was meant to take that one and divide it by 2. Let's see. Let's divide it by 2. Let's see what we get. That one's 43. Didn't want that either. So both of these guys are wrong. Dividing by 2, dividing by 4, both didn't work. So let's try the next guy. We have 5 squared, and this will be 5 times 6 over 2, and then that will be 6 squared. So let's try this here. We have 5 squared plus, let me grab my fraction. Oopsies. Let's quit out of there. Let me grab my fraction. And I'll have 5 times 6 in the numerator and 2 in the denominator, and then plus 6 squared over 2. All right, let's see. 58, not what I wanted. Okay, that's all right. Let's try one more. 5 squared plus 5 times 6 plus 6 squared, oopsies, 6 squared over 4. And that's what we wanted. We found it. All right, let's go for the next one. Oh boy, this looks like a bunch of intimidating math, but wait. I see a bunch of variables in the question stem, variables in the answer choices. This is a straight up variable dance party. Let's do it with plug-in. Looks like we have to plug in for x and y. So let's pick x. I'm gonna pick, 2. Let's make y 3. So I'm going to put this right into my original equation. Take a look. Y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus 8xy. Okay, so anywhere I see my x, I'm going to replace it with 2. So that's going to be a 2. That's going to be a 2. That's going to be a 2. That's gonna be a 2. Anywhere I see my y, I'm gonna replace it with 3. So that's gonna be a 3, 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 and I'm gonna put this whole darn thing into my calculator. Alpha y equals, grab myself a fraction, 3 plus 12 in the numerator, and in the denominator, I'm gonna have 2 minus 8, exit out of there, put a little plus sign, alpha y equals, grab myself a fraction bar, 3 times 2 minus 8 in the numerator. In the denominator, I have 2 squared times 3 minus 8 times 2 times 3. Hit enter. -2. All right. Now I'm going to go to the answer choices, and whichever one gives me -2, that's going to be my guy. All right, I'm going to zoom in a little so we can see these guys really well. So trying out A right now, I'm going to grab myself a little fraction bar. And again, anywhere I see X, I'm going to put a 2. Anywhere I see a Y, I'm going to put a 3. So here I have X, which is 2, times Y, which is 3, plus 9 times Y, which is 3, plus, oh, I started on the wrong one. Let me try again. We're trying A, right? So we're gonna do 2 times 3 plus our Y, which is 3 plus 4. That's our numerator. And then that's our numerator. So we're gonna take our little fraction bar and we're gonna put 13 in our numerator. And then in our denominator, we're gonna get 2 cubed times 3 times our Y minus 16 times our 2 squared times our Y, which is 3, plus 64 times our X times our Y. And let's see. Yep, that's not -2, so forget that guy. All right, let's try the next guy. Let's grab our little fraction bar. In our numerator, we have 3 times 2 plus 9 times 3 plus 12. And in our denominator, we have 2 squared times 3 minus 8 times 2 times 3 plus 2 minus 8. Not that guy either. All right, for the next guy, let's grab our fraction bar. You might be thinking, Donna, this is taking forever. And it's like, yeah, it kind of is. But guess what? We're definitely going to get the answer because we're using plug-in. So here we have 2 times 3 squared plus 13 times 2 times 3 minus 8 times 3 in our numerator. In our denominator, we have 2 squared times 3 minus 8 times 2 times 3. Let's see what we get. -2. That's our answer. But do we try them all? Yes, we absolutely do. So we're going to go and just try that last one. So that's 2 times 3 squared plus 13 times 2 times 3 minus 8 times 3. And in our denominator, we have 2 cubed times 3. Oopsies, that's in the numerator. Let's delete that. 2 cubed times 3 minus 16 times 2 squared times 3 plus 64 times 2 times 3. And that is not what we wanted. So we found it. So again, stuff like that might take a minute, but this is an advanced question. This is a challenging question. To be able to guarantee it for ourselves just using a calculator, that's some pretty good stuff. So let's see our next guy. Which of the following expressions is equivalent to this funky town thing right here? X squared minus 2x minus 5 over x minus 3. Look at all those variables in the answer choices, variables in the question stem. They're not asking us for a number. They're asking us for a bunch of expressions. So let's go ahead and plug in. What do we want to make x? I'm going to pick 5. I like to keep things positive, and if I pick 5, that denominator is going to be positive, and it'll make me feel happy. So let's do that. Let's put a 5 in for our x and see what we get. So here we have 5 squared minus 2 times 5 minus 5, which makes my numerator 10. Grab my little fraction, put 10 in my numerator, and in my denominator, 5 minus 3. Okay. well, looks like 5. 5's my answer. So put in a 5, whichever one gives me out of 5, I win. So let's try answer choice A. 5 minus 5 minus, let me grab my fraction, 20 over 5 minus 3. Does that give me 5? Nope, not my answer. Notice the next one's really similar, so I'm actually just going to grab that. I'm just going to go back and edit the numerator because it's the same, except for that's going to be 10. It's going to be 10 right here. I'm just going to delete and change that for a 10. Hit enter. That's negative 5, so not what I wanted. I wanted positive 5, so not that one. All right, let's try the next one. 5 plus 1 minus, gonna grab my little fraction bar, 8 over 5 minus 3. It's negative 2, not what we wanted. All right, looks like this one's just the same as this one here, except for that 8 in the numerator is a 2. So let's go back and see if we can change that up to a 2 and see what that is. That one gives us 5. That's our answer. You know, this is long division otherwise, so very, very nice we have this technique. All right, let's see here. If A equals C plus D, which of the following is equivalent to the expression of x squared minus c squared minus 2cd minus d squared? All right, it looks like our variables here in the answer choices are giving us a strong plug-in vibe. We're also noticing that we have variables that are related here. So if we're gonna plug in for them, we have to make sure we're plugging in C and D and finding out what A is. So if I make C 2 and D 3, it looks like my A would be whatever 2 plus 3 would be, which is 5. Okay, now that we have that. But those aren't our only variables. We also have an X in here, so let's pick X. Let's make X 6. All right, so let's see what this is so we can see what would be equivalent to it. So we have x squared minus c squared minus 2cd minus d squared. So let's swap out all my c's with 2's. Let's swap out all my d's with 3's. Let's swap out all my x's with 6. And let's punch that into our calculator. 6 squared minus 2 squared minus 2 times 2 times 3 minus 3 squared. So we're looking for something that equals 11. Okay, so now we're gonna put X and A into the answer choices and see which one equals 11. So this will be 6 plus 5 squared. That's gonna be in parentheses 6 plus 5 squared. 121, that's too big. All right, this is gonna be 6 minus 5 squared. Let's see, 6 minus 5 squared, that's just going to be 1, so not that guy. C is going to be 6 plus 5 times 6 minus 5. Oh, that one gives us 11. We'll keep that one in. And then the last one is 6 squared minus 5 times 6 minus 5 squared. That's negative 19, not what we wanted. Looks like we found our answer choice. All right, let's try the next one. If A and C are positive numbers, which of the following is equivalent to the square root of quantity A plus C cubed times the square root of A plus C? Again, you'll notice that word equivalent comes up a lot, and that means it's a plug-in because we just want them to be the same, but instead of making them the same algebraically, we'll just make them the same with real numbers. So let's pick an A and a C. I'm gonna go for 2 and 3 because you know how I love that so much. Okay, so now we want the square root of A plus C cubed times the square root of A plus C. Okay, so anywhere I see A, I'm gonna swap it out with a 2, and anywhere I see C, I'm gonna swap it out with a 3, so that's gonna be a 2, and that's gonna be a 3, and that's gonna be a 3, and that's gonna be a 2, and I'm gonna pop this right in my calculator. The square root of quantity 2 plus 3 raised to the 3rd power times the square root of 2 plus 3. All right, 25. Looks like I get 25. In goes the box, out comes the circle. Well, 2 plus 3, is that 25? No, that's 5. 2 squared plus 3 squared, well, let's pop that in my calculator. 2 squared plus 3 squared, that's 13, not what I'm looking for. This one here is 2 squared plus 2 times 2 times 3 plus 3 squared. That's 25. That is what I'm looking for. We'll keep that one in. Now last one, that's 2 squared times 3 squared. That's 36. Not what I'm looking for. All right, looks like we found our answer. Okay. Last one. Oh, no last one. That was the last one. Well, I hope you enjoyed this little foray into Plug-In and Backsolve. I would encourage you to go back and look through each one and see what they have in common. What makes the plugins all look the same? Look at all those variables. What makes the backsolves look the same? Look, this is like a list of numbers and the answer choices. Keep your eye open for these, and anytime you're stuck on a problem, remember not to move on until you've asked yourself, could I plug in or backsolve this? You might be surprised.